Welcome to the Office of Undergraduate Research Education Series. Today is the Research Data Management Fundamentals, and our speakers are Madison Golden and Kaylee Alexander, who was unable to attend today. This is a virtual event which is being recorded, so please mute yourself and turn off your camera to ensure the best experience. If you have questions, please use the chat feature, or you can unmute yourself when you're invited by the speaker. And this is the QR code for our event evaluation. We would like everyone to fill this out, but we want to remind the Europe and the early exploration scholars that they must complete this evaluation in order to receive credit for attending the event. And we wanted to remind you the mission of the Office of Undergraduate Research is to facilitate and promote undergraduate, student, faculty, collaborative research and creative works in all disciplines throughout the University of Utah campus. And we acknowledge that this land, which is named for the Ute tribe, is the traditional and ancestral homeland of the Shoshone, Paiute, Goshute, and Ute tribes. The University of Utah recognizes and respects the enduring relationship that exists between many indigenous peoples and their traditional homelands. We respect the sovereign relationship between tribes, states, and the federal government, and we affirm the University of Utah's commitment to a partnership with Native nations and urban Indian communities through research, education, and community outreach activities. And now I'm going to turn it over to our speakers today. Madison, you can take it.
Great, thank you so much, Shelley. So hi everyone, my name is Madison Golden. I am one of two research data librarians at the Marriott Library on campus. Me and Kaylee Alexander are both here to support both student and faculty researchers in any of their needs as far as handling data during the research process. So anything from collecting data to doing any of the research data management best practices and techniques that I'm going to be covering today. And we'll have our contact information and website and stuff, everything at the end as well. So my plan for today is going to be to cover an overview of research data management, including key concepts and best practices. And then following that overview, I'm going to cover how you can sort of apply those topics and concepts to your own research process. And finally, how all of those concepts should be presented in data management plans, along with tools to help you complete them and an overview of data management plans in general. So it'll be a little bit of a lot of me talking today. So any questions, if you guys put in the chat, I'm happy to answer them as we go as well. So I'm going to start by defining research data, as the scope is often more broad than you might initially assume. So understanding what concepts constitutes data in the research data lifecycle is key to proper data management and completing data management plans. So research data management comes in many shapes and forms, physical or digital, big or small, uniform or varied. They can range from lab or survey results to ethnographic notes, demographic information, interview transcripts, audiovisual materials, economic indicators, government records, text mining results, and catalog or archival records. So really we can consider, a tabular data set in a CSV data, but we can also consider photos and audio recordings and things like that data as well. So then research data management, as defined by the National Library of Medicine, is the organization, documentation, storage, and preservation of the data resulting from the research process, where data can be broadly defined as the outcome of experiments or observations. And then it goes on to list some of those broader range of data that I just mentioned. And so the concepts in this definition, like the organization, the documentation, and storage, are pretty broad, and they're made up of a lot of smaller activities and decisions that you make throughout the research process. So in the following slides, I'll kind of go into more detail on what those specific practices and activities might be for you guys. And our goal in sharing these tips and information, while it covers a lot and covers a lot of different things that can happen during a research process, the goal is not really for each researcher to do every single thing, but to really think about the decisions that they're making with data along the way and how to optimize, whether it be the file structure that you have for storing your data to maybe generating metadata or descriptive information about your data set. Research data management can save time and improve workflows for your research practice by making key decisions ahead of time, like what software you're going to be used to analyze data, how data might need to be processed or cleaned prior to being analyzed. It also creates a clear documentation trail of those decisions. So if you were to work in a lab of a faculty member here and there was a lot of staff turnover, for example, creating sufficient documentation for the people following you or the people that came before is going to be super helpful. Standardizing research practices also promotes responsible research by increasing the reproducibility and efficacy of your work. Especially as young researchers, this creates a really strong practice and good habits around responsible research, especially because those data management plans that I've mentioned a couple times aren't required unless you have a funder or a publisher that wants you to do it. But getting into the habit of doing things like making a data management plan now will really help you down the line when it might become a requirement in your career or your studies. And then by sharing data that's been effectively managed, there's a lower barrier for entry and engaging with research data, whether that be for educational purposes or for researchers with limited resources. One of the big outcomes of federal policies that now require data to be shared is that lower barrier to entry, and also being able to test for reproducibility in a wider range of data sets and not having that barrier where you're just reading an article and they say they have XYZ data and you can't really go look at that and validate that for yourself. So moving on to kind of when these concepts come into play and what that looks like, the research data lifecycle is a really helpful model for understanding the smaller activities and practices involved in larger research data management topics. So while this graphic may be new to some of you, the steps involved in the research process are probably going to sound pretty familiar. And in the next slides, I will speak to each step of the cycle and what exactly will happen at each stage. So the first one is going to be planning. This is when you have your idea for what you want to study, or you're working in a lab that has that idea. They might be applying for grants, designing experiments, or finding sources of data, and generally preparing for the collection phase. For research data management, this is when you would be creating a data management plan or just making those decisions ahead of time. And then it also entails making decisions and documentation for all stages of the cycle. So when you're doing that planning, it's involved in collecting, processing, analyzing, preserving, and so on. So then collection is either acquiring an open access data set or a data set that's just generally freely available online through like the government, for example, or collecting the data through experimentation. There's a lot of great sources of data sets that you can use for free and combine with other ones perhaps to engage in novel research questions. We do have a LibGuide on this topic, and we can do consultations to help you guys find and navigate some of those different sources. Some really common ones, though, are going to be data.gov or census data. There you can see all the government data that's being collected you'll have access to. There's also larger surveys like the National Household Education Survey for like social science research purposes, or we have business data sets like those from the Mergent database available through the library, or other ones like PubChem that have store like bioassay data. I don't know if that's how you say assay or not, but so more scientific databases as well. And then for research data management, this is when you would do things like document what instruments you're using for data collection, methods used to interpret the data, And that's also when you're going to begin to start formulating a file naming and organization structure and selecting an appropriate storage location for your data while you're in the research process. So there's several recent different ways you can do that on campus. So each have their own pros and cons as far as the size limitations of what you can put in there and also the level of security that might potentially be an issue if you're using like human subjects data or something like that. So we have things like that's like Google Cloud versus using like Microsoft 365 versus using something like SharePoint versus Ubox, so we also have a page on our LibGuide where we kind of like break down those different options and some of the considerations, but IT also has pages on that as well, I believe. So I'll also be bringing up continual documentation at almost every one of these stages. It might seem a little bit redundant after planning, but a lot of times when you start a project, things change when you actually get to doing it. You might not have a concrete idea of everything that's going to happen in your research process. So continuing to write down maybe what differed from your plan or new things that arose is going to be really essential. So then processing and analysis both involve data cleaning, transformations, creating visualizations, and forming your final results. There are many resources on campus for processing and analysis, like instruction sessions from the Center for High Performance Computing or carpentry's workshops on the Health Sciences campus, and free software from the library's Knowledge Commons. There's also statistics core on campus and a couple other like high performance computing and imaging cores. And then for research data management, you'll also be documenting how these actions were performed for the sake of reproducibility and paying close attention to best practices like file naming and organization, as well as ensuring data and other outputs are stored correctly and safely. So the file naming and organization becomes especially important at this processing and analysis stage. And that's just because that's when you start to have multiple versions of a data set. So you might have the original data set that you started working with, maybe a post-cleaning version, maybe an analyzed version, maybe your visualization as well. So making sure that it's very clear which one is which, so you can kind of see the steps that were taken in between each stage of the data. So preservation and sharing both involve selecting an appropriate long-term storage location and choosing what stage the data should be shared at, whether that's the initial data set, maybe just a visualization, but it's essential to think about what would be the most helpful to a future researcher. And the sharing really only applies if you either just want to share your data openly or if you're required to, if you had a funder or a publisher involved. So if you don't, that's not as big of a concern, but the university does have a institutional data repository where you can store data for free as long as you're students. And we help a lot with that whole process, pretty much do the whole thing besides assisting in creating some metadata. But back to preservation, for research data management, it's really, really important when you're finishing up a research project that you would create persistent identifiers if your data is going to be shared. So digital object identifiers or DOIs, and then ORCIDs are a type of identifier for people. So if you don't have one, you might want to, just because they're able to kind of keep everything that you might publish or share over the course of your career as scholars linked together in one place, which is really nice. Again, if you're going to be sharing, you'll need to define who gets to use that data and how. So maybe you only want people to be able to use it for non-commercial use, or maybe you just want it to be in the public domain, period. But those kinds of decisions are all being made now. Also, formatting your data set, I'll go a little bit into later, but trying to make the format and metadata as accessible as possible. So then sharing, kind of like what I said before, if you were in a position where you had a funder or a publisher working in a lab that did, selecting a repository for that data can be a little bit of a tricky process that we support a lot of researchers on. There's a lot of considerations that would go into where you're going to store, basically based on how big of a file size they would allow you to deposit, what formats or types of data, maybe they're images only, maybe they only accept CSVs or something like that, whether they're sensitive data. So if you're working with human subjects, if you're working with certain animal populations, that can be an issue. And then some do cost money, some are free. That's a pretty big differentiator for a lot of people. And then the last stage in the life cycle is going to be reuse. That's when the data set can be found, accessed, and repurposed by others. And with this process complete, it's recommended to update your data management plan if that's something that you've created to account for any changes or deviation from the plan that occurred during the research process. And then since the responsibility for the data may be passed to the selected repository for sharing, for example, you may document that as well for the purpose of chain of custody that I'll get into a little later with the planning. So now that we've kind of talked about what the whole research process might look like data management planning wise, I'm going to cover the FAIR data principles. So the FAIR data principles are basically stand for data sets should be findable, accessible, interoperable, and reusable. So the FAIR organization basically created these principles with a set of guidelines of how to meet each one, which basically just results in the data being as reusable by future users as possible. And while the focus is on reuse with these, the actions and recommendations for each of the principles are all data management best practices. So they can be applied to any data set, whether or not it's going to be shared for reuse or used by anyone else down the line. So the first principle is going to be findability. That's accomplished through several actions that help others search for and locate your data set. It's basically search engine optimization for data sets. And you just want to make sure that your data set won't become unavailable due to broken links. You want to include enough information for search pages to pull that information. And then sharing the data set if you're going to be doing that in a location that's searchable and findable. So some actions to consider to meet that principle would be creating persistent identifiers like the DOIs or ORCIDs that I mentioned earlier, selecting or creating a metadata schema that's related to your domain of research. So that basically means how you're going to go about describing your data. So a metadata schema might be like you should enter the title of the data set, a description, different fields like that. And you can just kind of Google if there's a national agency related to your domain of research, like the National Endowment for the Humanities or the National Science Foundation. A lot of times they provide different information or guidance on how to describe data. So then, accessibility. Making data accessible entails making the information in the last section searchable and available, and that's kind of more on the technical side and not something you would have to worry about as the researcher. So for example, we make sure that the institutional data repository we have on campus is compliant with certain standards so that search engines can pull that information or other aggregated sources can pull that information. So as a researcher, the only thing that you would really need to consider with this principle is asking the repository that you may or may not use if this is something that they do or not. Interoperability refers to future users of the data set being able to open and work with that data using standard and freely available tools. It also means giving future users enough information about how the data was collected, processed, and analyzed for them to be able to make sense of the data, including information on if any software or code was used in your project. So some actions to meet this principle would be including that code and software information we discussed earlier, using standard file formats and openly accessible software. So that would be instead of using, if you were using Adobe Photoshop and you exported that file in the Adobe Photoshop file format, then no one who doesn't pay for Adobe can't open that photo. So instead, it would be things like exporting it to something that anyone could open on their phone or computer. And that applies to pretty much any data type, just wanting to make sure that pretty much anyone on a computer with no software downloaded can still access and use that data. And then it's also if you did not collect that data through experimentation, maybe you did pull census data, maybe from multiple sources, recording what the source information was will help people kind of retrace your step and find that original data. And then lastly, in order to increase reusability of a data set, licenses that let features know to what extent they can use the data is really key. So I kind of mentioned this earlier, but the Hive uses Creative Commons licenses. So they basically define if your data can be used for commercial use, education only, public domain, things like that. Also giving information on the source of the data and how it's been altered from the original source is essential. So if you did, like I said, pull census records, then saying what sort of manipulation possibly happened after the fact to create the final data set. And then using any standards that may apply to the field you're working with, like I've mentioned a couple times, is also really key. Some other actions include performing quality control. So if you just finished working with a data set, maybe you even wrote a piece of code to go with that data, opening and running both of those things to make sure that they're still openable and working in all the ways they should is really a great idea. Also including information on, like I said on the last slide, like where the data was derived from, whether or not it includes sensitive or restricted information. And if it does, possibly performing things like de-identifying that data set so that, you can bypass some of the restrictions that would have been there if you left the data sensitive. Okay, so now that we've covered some of the basics of data management, I'm going to cover what, why, and how our data management plans. So these can help you write your own plan as a researcher to cover all of your research data management best practices bases. And it's also maybe helpful if you're not required to make them yet. A lot of shared data sets may include data management plans. So if you were to review one, you would kind of understand what it's trying to say and some of the important things you might want to look for before using a data set. So the current policies around data management plans were developed by federal funding agencies for creating the plan. So all of this started with the OSTP memo, which was published in 2022 by the White House. And that memo basically said that all federal agencies should develop plans for providing public access to the outcomes of federal funded research. So agencies like the National Science Foundation, National Institute of Health, pretty much all of the other ones did this, but the NIH was one of the first. So their policy was kind of the bedrock for many other policies. So that's the policy that I will be covering today. So you can just keep in mind that how they describe what a data management plan should be and how sharing should be done really closely aligns with pretty much any other agency that is requiring these plans. So moving on to the actual policy, it's best broken down into two parts. The first is on the left-hand side of the screen. It basically says that researchers must submit a data management plan outlining how they're going to meet sharing requirements and manage their data along the way. The second part basically just says that researchers must comply with the plan that they create, which is, of course, the more difficult part. And while the concepts of these plans develop to meet policy requirements, they are being adopted more and more by researchers who are not required to create them, just as a best practice in data management. So what is a data management and sharing plan? They are typically a 2-page document. Not all agencies say a certain page limit, but the NIH does, I believe. And although they do vary in length, they are always submitted as part of a grant proposal. So it'll be reviewed but not scored in a grant review process. The plan covers 6 elements. Those are data type and description, related tools, software, and code, standards, preservation and access and distribution, and oversight. So I'll spend the next slides going into detail on each one of these sections. And other funding agencies may have variations on these elements, but regardless of how they're divided, the main content will stay the same. So for example, the National Science Foundation uses 5 elements. Those are expected data, data format and dissemination, data storage and preservation, access, roles and responsibility, and period of data retention. So they pretty much mimic the NIH there. And then lastly, data management plans are not set in stone. So like I said before, adjusting as you go through the process is really key. And that's especially true if you're creating one as a best practice. So all grant proposals in government agencies do require these plans, but there is a short exception list as far as the data sharing component goes. So that's kind of just things like blood samples or raw lab notebooks you do not have to share. So the first element of data management planning is to briefly describe the scientific data that's going to be managed, preserved, or shared. So the first part of that is saying what data types and then the sizes and amounts of those types are going to be collected during the process. So you can think of this as a description of the information to be gathered along with the nature and scale of the data that will be generated or collected. And so data types can range from data in a simple CSV to samples, simulation data, electronic lab notebooks, models, etc. It can be helpful to think of those types in the categories of observational data, experimentation data, and simulation data. And then the formats are going to be file formats. So if they're digital, along with the size of those files. So that's where if you had an image, you would say, I'm going to be sharing these in like a PNG format, for example. And then each image I expect to be maybe 5 gigabytes. And the part where you are estimating the file size is really important because it kind of dictates where you can share and save that data while you're researching. But it's also a little bit hard to predict at the beginning, especially if you haven't done a certain type of research before. So we do have a tool on our website that can kind of help calculate that. But if you Google like data or file size calculator, those tools can help you too. So description of data to be shared is summarizing which data will be preserved and shared for the project. That's not always applicable if you're not required to share, if you're not required to make one of these plans. But we usually just advise that to be whatever researchers consider would be the most helpful for a future researcher in continuing that line of work. It might also be based on ethical, legal, or technical factors, such as if you kind of fall under like the HIPAA regulations, for example, that will dictate what you can and cannot share. And then lastly, listing metadata and other documentation like a README file for code, if that's something you're using, that will be accessed or be accessible to assist with interpreting the data. So that's just kind of like that reusability principle of making sure that everything's in a form that will be accessible to others. So if you need software or code to run the data, that should be shared along with the data. So element 2 is defined as indicating whether specialized tools are needed to access or manipulate the scientific data to support replication or reuse, and the names of the needed tools or software. So very similar to the last component I discussed. So the first section is going to be a simple list of tools, software, or code. It's also a best practice to give a short description about how each one is used and how those files relate to each other. A simple example of that would be describing the use of Excel for data analysis, and maybe using a software like NVivo for data processing if you're using qualitative data. Access to tools is also very important, providing information on how you can access the tools and potentially giving alternatives if you're using proprietary tools. So for example, if you're using a software provided by the school for free that comes at a large cost, otherwise like Adobe, then you can maybe Google an open access version of the tool and recommend that people who don't have Adobe can use that instead. So then you also have to consider the longevity of each tool. So for example, we've had researchers say that they developed an open access software for manipulating their data. Later, that open access tool was bought by a large company, and it created a lot of accessibility issues. So considering whether or not a software or a tool will be usable 5 to 10 years down the line is very important. Element 3 is an indication of what standards will be applied to the scientific data and associated metadata. So disciplinary standards are field by field for what format data typically comes in, how data identifiers or dictionaries are formatted, styles or types of documentation that's provided along with the data, and then also whether or not you will be adhering to those. So the lack of standards field would be where you would say no standards exist, or I will not be adhering to those, and this is why. So an example of this is like the National Cancer Institute has a list of data standards for genomic data. So if you were working with genomic data, maybe you'd refer to those and say, these are standards that apply to my field and I apply them to this project. Or places like the National Library for Medicine released common data elements. So it's a common way to describe different types of data. And yeah, like I said, not all fields have those. Some fields have variations, but regardless of all of those things, this is where you would record that type of information. Element 4 is about preservation and access, including if you have a repository that you selected for long-term storage of the data after the project is over, and what maybe metadata is used for people to find that information. So whether that be things like a title, a description, keywords, subject words, things like that, dates, all that kind of thing. So selecting your repository is a big area we can assist with if that ever comes up. The NIH who wrote this policy is pretty particular about what they consider to be a repository. And there's quite a few factors. We on our LibGuide also have a flow chart to kind of get people familiar with some of those decision-making factors as far as selecting a repository for long-term storage. And again, the Hive is always an option there. It's especially great for student researchers who maybe don't have a really big budget or need a really large storage location. So this is also a time to describe any persistent identifiers that are going to be created. So if you have an ORCID to identify yourself, you would list it there. If you are going to be having a DOI for the data set, you would also say that. And you'll then list any metadata being created for the data set, like the dates of collection, like I said, a title, other creators, subject words. And then lastly, you'll state when the data will be made available for how long. So a lot of grants say you should share your data at the end of the funding cycle, or when the data is published, maybe whichever one comes first or second. And then how long. So a lot of grants or publishers will say, if you publish in our journal, you need to make your data set available for 5, 10 years, 7 years. Those are pretty common numbers that we see. So then to make sure that you note that timeline and choose a place to store your data where that can accommodate that timeline. So element 5 is similar and focuses on the factors affecting access, distribution, or reuse of the data. One aspect of that is going to be protections like informed consent, privacy, and confidentiality procedures for the data. It also includes measurements or measures like de-identification. So the university's Office for Sponsored Projects provides detailed information and policies on that sort of data sensitivity categories, and they can assist you in navigating those aspects along with us at the library. And if you will be using a repository that supports controlled access, so you can define like only people from my university, for example, can see this data, you can list that here as well as a way to say how you're sort of dealing with those concerns. And then lastly, any other sharing restrictions like HIPAA, university policies, or agreements that are affecting this data should be listed, as well as how they may be circumvented, going back to that controlled access section. So now our final section is the oversight of both the data management and sharing plan during and after the compliance of the completion of the project. So you'll list both who is in charge of monitoring compliance with the plan and who's responsible for carrying out each section or task in the plan. So often the PI or person writing the plan will be responsible for carrying it out, but it could also be the lab staff, research administration, student researchers like yourselves, or repository administrators like myself. And that's the whole plan. And now that I've shared all of the overwhelming amount of things you need to consider during a research project, DMP tool may be your new best friend, and at very least extremely helpful in doing any sort of data management planning or continuing to familiarize yourself with these topics. So this tool is free for the University of Utah. We have single sign-on that works at DMP Tool. It's a website, dmptool.org. After you log in with your university credentials, it provides templates to build your plan step by step. So it basically follows the same structure of the sections that I just described, but for each one, it gives you a specific question of how to fill in that section. It also provides guidance from us at the library, as well as the different funders put in advice for each section. They provide sample answers for you to see how someone else might write that with fill in the blanks for your project specific information. And then those templates pretty much come based on funders or institutions. So the University of Utah has several templates. There's templates for pretty much every government agencies. There's many other universities that have templates on there as well. And you can also see other published data management plans. So if you were to have logged in, you would see a button at the top, if you can see my mouse, that says public DMPs right under my name. And that allows you to basically go in and read what other researchers have written about their work. And you can also see maybe what funding and information or agency that they got their, that they worked on that with. If you're interested in a certain field of research or a specific funding agency in the future, for example. I've pointed several researchers here. If they weren't sure what their agency was going to require and they wanted to prepare, it's a really great place for that. And then the last thing that I point out about this tool is that this is what it'll look like when you're about to fill out your plan. Each of these fields are expandable and collapsible. If you want to request feedback after making a plan, whether it be a test plan or a real plan, you can request feedback directly through the tool, and it'll just send an automated email to me and Kaylee that someone wants some feedback, and we can go in there and review it and provide any tips for how it could be improved. So now that we've covered all of that, I'm just going to say a few words about the other resources and support that are available from the library and the University of Utah. So the Marriott Library has me and Kaylee. We can do consultations and trainings on all the topics covered today, or just email back and forth, whatever you need. We also have our LibGuides and a website for on-demand information. We control the Hive, which is the institutional data repository. We provide curation support. We facilitate the whole process. We create persistent identifiers. It's a pretty full service process. And then we have the Knowledge Commons at the library as well that can provide you with access to pretty much any analysis or processing software you might need. Across the rest of the University of Utah, I like to point out the Data Science Hub that includes the Data Science Institute Delphi. They provide analytic and processing instruction through the Carpentries program. They also have a lot of other educational events and funding opportunities that are totally open to students. I've been to several data science networking events with students in attendance looking for research collaboration or just to meet more faculty members. So that's a pretty cool opportunity. We also have the VPR's office and one of the ORIC, which is housed within the VPR. They provide responsible research policy, data classification policy, research education, and they also provide data management plan support in addition to us. And then lastly, we have the Center for High Performance Computing on campus, which is really cool.
Madison, one person asked any tips on how to organize large sets of qualitative data.
Yeah, I think that that's probably a question that we could have a little bit of a longer consultation about. I think that a first step whenever you have a large qualitative data set, and I'm not sure if this is implied or not, but is performing some processing. So there's a lot of tools like one's called OpenRefine and Vivo, things like that, that can kind of be a really good first step in figure out how you're going to organize and make that data usable from its maybe original qualitative, a little bit messy state into something more analyzable. So that's what I would say to start. I think beyond that, diving into possibly disciplinary standards or any sort of common organization methods based on the field of qualitative data could be really helpful, either if they have concrete guidelines or maybe examples of other data sets that you could look at. But that's what I would say, unless I could see the data set maybe provide a little bit more detailed ideas.
Do you have any ideas on how to deal with data silos?
I don't know if that person necessarily has any more context. I think that when you have like, I'm going to just, I guess, assume this is kind of talking about having disparate sources of data that maybe don't speak to each other, like you can't pull data from multiple sources together or it doesn't work to combine for analysis purposes. I think I could definitely walk anyone through some techniques to sort of break down a data set essentially without getting too jargony. I'll describe it as that to kind of get it to a place where those two things can be more interoperable. But I think that the issue with data silos is that what we're really trying to fix with data management and those FAIR principles is to make sure that by the time a data set ends up with someone or is available, that it's not going to end up in a silo. So I feel like a lot of times our measures around data silos are largely preventative, if that makes sense.
One person asked, are there certain devices, applications, etc., that we use as researchers that should be using now rather than others to better accustomed?
Yeah, I think eLab notebooks are a really big one that we talk about. I know we can access those for free through the university, and that one's huge. It's talked about a lot. I also think using things like data management plan tool or DMP tool are a really great thing to familiarize yourself with. I think they're going to become more and more popular over time. I also think like this is my high horse. I've said it many times, so I apologize. But really, if you know a field that you're going to be going into, a lot of typical tools or recommended techniques, um, ways to create documentation, places to store your data. So many of those decisions, their root is going to be in what type of research that you're engaging in and in what field. So if you're using quantitative data and you're in the hard sciences, like there's going to be a whole set of tools and standards and best practices that apply to that might not be related to someone using largely qualitative data in the humanities.
Okay, I want to remind everybody about the event evaluation. This is a QR code, and I just put the link in the chat. So everyone, please complete this. But the Europe and Early Exploration Scholars, you must complete it to get credit for attending this event. And thank you so much, Madison, for this great presentation. We really appreciate it. I just want to remind everybody that the Office of Undergraduate Research, we're located in the Sill Center. We're open Monday through Friday, 8 to 5. Our website is our.utah.edu, and you can email us at our@utah.edu. And this QR code is if you want to join our mailing list. Well, thank you again, Madison. We appreciate it.
Thank you so much for having me.